Okay, here we are. This is quantum mechanics video 4. I think I have 3 up, right? I think this might be the 4th one, if not the 5th one, whatever. Understood. I'll number it when I put it up. Okay. Now we're plugging some holes with quantum mechanics. Something that's very difficult. You know, there are a lot of chemists who don't particularly understand quantum mechanics that much. So quantum mechanics is a pretty fierce course of study. In college, we used to have to take a course called quantum mechanics. It was deadly. It was really hard, and you knew the people because they had these bright books, bright colored textbooks, and on the binding of the book was quantum mechanics. So you knew if somebody was in a desperate way walking around with that thing, because I'd walk it under my arm and it would be bright, everybody could see you have it, and you know, everybody who took that course looked like it was so hard. Anyway, so one of the aspects, and then we're just going to make a quick video, is the photoelectric effect. What can you tell me about the photoelectric effect? Anybody? They're reading feverishly and on BYOD, bring your own devices. Dylan, what do we got?
Electrons are ejected when light shines on a metal.
Okay. Electrons are ejected when light shines on a metal. I like that. So here I have a metal. Here I have a light ray. Right? This is the metal. And then the electron is driven off. Okay? What else? Photon,
Photons.
photon, electron.
And
Photo, electric. Photon, electron. Photoelectric effect. And who won the Nobel Prize for that?
Planck. Max Planck.
No. Albert Einstein won the Nobel Prize for the photoelectric effect. Yeah, you got that right, Dylan. Isn't that amazing? You know, you throw Albert Einstein's name around every once in a while, and it's usually the answer to a question. Yes, Lauren.
It says here that not just any frequency of
I love her South African accent. It's wonderful. Could you say that? Very melodic.
Not just any frequency of light will cause the photoelectric.
All right, not that's very good. Not just any frequency.
Yeah.
Now we know about frequency by the waves, the number of wavelengths that pass a particular point in time, right? The number of cycles per second, hertz, the number of frequencies. So something with a high frequency will have what kind of wavelength? Short or long? Short. Yeah. So say that again, Lauren. Not every photon of light will have the right amount of energy. Will have the right frequency or wavelength in order to eject this electron. It has to be just right, doesn't it? Matter of fact, it has to be pretty high energy, doesn't it? Yes.
It says Max Planck was working on the problem of how radiation on an object emits.
Max Planck. All right, why don't you pull that together a little bit to put it in your own words? You sound like an encyclopedia, and that's a little scary.
He's
okay? No, let's wait. We'll wait on that. That's very good, though, Mustafa. Very good. Excellent. Try to distill that down into something more usable. That's pretty heavy stuff. Max Planck. He did say the word Max Planck. What you want to? Did you finish the thing about the photon and the energy level and the frequency?
No, I stopped with quantum mechanics like the first thing.
Okay. Would you like to add anything to that? Her name is Lauren. She's from Pretoria. Wonderful child. Yes.
No, there's not really much, but it does say red light will not cause potassium to eject electrons no matter how intense the light.
Red light won't do it. So we'll say that again. Red light won't make potassium.
Yes, will not cause potassium to eject electrons.
Yeah, red light will not cause potassium to eject an electron, but no matter how intense the light is. So you need.
Very weak yellow light shining on potassium can be.
But very weak yellow light will do it because yellow is higher energy, right? So This is long, short, right? This is red, orange, yellow, green, blue, indigo, violet, right? The shorter the wavelength as you go. Yes?
Sir.
Hey, Matt. We'll talk later. We'll talk. Okay? Now, so what else do we have here? So this says that this has to be yellow to blue, right? Is that what you're saying? Yellow to blue in order to eject that electron. Anything less than yellow is not going to really do it, is it? Red, orange, yeah?
No.
And you also mentioned a name, didn't you? What was the name you mentioned?
Max constant.
Albert Einstein.
Max.
Blank.
Yes, Albert Einstein, yes. That's throwing his name around again. He's the answer to something, always. Max Planck, right? Max Planck. And what can you tell me about Max Planck? Yes, anybody? Yes.
He's a physicist.
He was a physicist. Excellent. Who else? What else was he? Yes. He was a physicist.
He lived in the 1900s.
He was German.
He was German.
Lived in the 1900s.
1900s.
Organized the quantum theory.
There was an SI unit of energy named after him.
An SI unit of energy.
Planck's constant. It was
SI unit called Planck's
constant.
constant. And what is Planck's constant?
It's 6.626 times
6.6. Hey, isn't it? What is it? 6.6.
No,
6.626.
Yeah.
What is it?
6.626
6.626.
times 10 to the negative 34.
What?
Joules time per second. Time-
Joules per second or joules?
second.
Times.
Yeah.
JS, right? Is that right? Yes? Okay. Planck's constant. That's going to become very important. Give me an equation with Planck's constant in it. I'll give you a hint. Energy. Planck's constant.
E
E
equals 6.626.
E equals
HV.
H nu.
Yeah.
Right? E equals H nu. Right? E, physicist, German, 1900s. Is that about right? Do we have a birth and death on
Yeah, but
Max? What do we got?
1958.
All right, but when was he born?
1858.
What is it?
1858.
1858?
Yes. And he died
Died
in
1947.
1947.
Age.
Long life, huh?
That's a long one.
Yeah, long
For
life.
that time, yeah.
Yeah, they're good.
He's 89 when he died.
He was 89 when he died?
Yeah.
Excellent. Now, if we know the following, we know that C equals wavelength nu, right? Is that right? We also know that E equals H nu, right? We also know that nu equals E over H. Isn't that correct?
Yeah.
So far? Where am I going with this?
You're going that E over H equals C over
C equals wavelength
nu.
E over H. Is that correct?
Yeah, it is.
Yes, is that correct?
Mm-hmm.
Yes? And that is Planck's constant. Are we done? I'm complete toast today. Now, what we want to do is we're going to make 2 or 3 more. The next class will finish it up. Remember, the week of the 24th is the test. I don't know what day it is, but the week of the 24th. Yes? Do you understand that?
Yeah.
The week of the 24th. Now, it could be Sunday, Monday, Tuesday, whatever. So you got to stay vigilant, yes? And the homework is going to be due, sorry about this, but the homework is going to be due the week of the 17th,
Next week.
next week. Understood?
Any day or
Just that week.
That
Thursday,
week,
'cause
that week. I don't know what day. I mean, it'll be that week. And if you have to turn it in that week. I'll tell you what, the earlier you turn in your homework, you'll get extra credit. How's that?
Okay.
Clear? Understood? All right? We're off.